Hey students, in this lesson we are going to prove triangles are similar. We're going to use the AA, angle-angle similarity postulate, and the side-angle side and side-side-side similarity theorems. These are different than theorems we use to prove triangles congruent. Go ahead and do the review there. I'll check back with you. All right, so here's our postulates and theorems that we're going to use. The angle-angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the angles are similar. And that's because of the third angle theorem. If you have two that are already similar, then the third one's going to be similar. Angles, side-angle side similarity theorem. If an angle of one triangle is congruent to an angle of the second triangle, then the sides of that include the two angles are proportional, then the angles are similar. And side-side-side similarity. If corresponding sides of two triangles are proportional, then the triangles are similar. All right, so in this one, notice that we have 2/4 is equal to 4/6, or 3/6. So we have two sets of corresponding sides where the ratios are proportional. Those two. And then we have an angle in between that's congruent, these right angles. So this would be side-angle side similarity. All right. So let's go ahead and use these here. So we have this one. We have angle R is congruent to angle N. And we have, and that's given. And then we have angle O is congruent to angle S. And that's because all right angles are congruent. All right. And that is enough because of the, I'll put this down here. Because of the angle-angle similarity theorem, we can now say that triangle RST is similar to triangle NOP. And that's because of the angle-angle similarity postulate. All right, on the second one, we are given that angle G is congruent to angle D. And we have, just doing a little math here, we know that angle H is equal to 60 degrees. Measure of angle H equals 60 degrees. And we know that the measure of angle F is equal to 95 degrees. So we can tell right now that the angles, three angles are not congruent, or the two angles are not congruent, so we're not going to say that these two triangles are congruent. All right, you try that. Sorry, I said not congruent. What I meant to say there was not similar, according to the, we would need all three angles to be congruent. All right, are the triangles similar? So write a similarity statement here. So let's see what we have. We know that, let's check out the ratio of RK over LP. That's equal to 10 over 5. The ratio of KS over PD is equal to 24 over 12. And the ratio of RS over LD is equal to 26 over 13. Well, all of those are equal to 2. So according to the side similarity theorem, the triangles are congruent. So triangle RKS is similar, sorry I keep using the word congruent, is similar to triangle LPD. All right, let's check out this other triangle here. Again, we're going to check these ratios. Well, we have a common angle here, angle T, so we're going to just say that angle T is congruent to angle T, and that's by the reflexive property. And then we're going to say, check out the ratios. ST over RT is equal to 10 over 14. And UT over VT is equal to 12 over 16.8. Let's just simplify those ratios. We get 5/7 here, and we get 5/7 here. So we get those two ratios. Ratios of corresponding parts are equal on those sides, on two sets of sides. So we can say that triangle RTB is similar to triangle STU. And our reasoning would be the side angle side similarity. That one. All right, you try that. All right, so this one we're gonna actually do some proving here. All right, so we know that angle STL is going to be congruent to angle CLT because they're both right angles. And then using the triangle angle sum theorem, we can show that angle SLT is equal to 55 degrees. And then that's going to equal angle LTC. And then we're just going to use angle-angle similarity to show that the triangles are congruent. So I'm going to write down those steps. All right, you try proving one here. Just fill in the reasons. All right, last thing we're going to do is use this idea of similarity to solve a problem. Ben places a mirror 40 feet from the base of an oak tree. So let's draw a little oak tree here. And he puts a mirror 40 feet away. So here's our little mirror thing here. And that distance is 40 feet. Like that. When he stands at a distance of 5 feet from the mirror, he can see the top of the tree in reflection. So let's draw another line here and call it 5. So that's to there. And he's standing there. So here's Ben. All right. He can see the top of the tree in the reflection. So he's peering down from here. And gets that. And he sees the top of the tree there. So if Ben is 5 feet 8 inches tall, so everything else is in feet, so maybe we should put this in feet. 8 out of 12 is 2/3 feet. 5 and 2/3 feet. All right. We want to find H, and we know from the similarity theorems that if we have congruent angles, which we have here, and the right angles, so by angle similarity, we know these are similar, so that means that my ratio of 5 and 2/3 to H is going to equal 5 over 40. So I'm going to do 5h is equal to 40 times 5 2/3. And then divide that by 5, and that should give me the height. So if I divide that by 5, I get the height of the tree is 45 and 1/3 feet high. All right, you try that. All right, that's it for this lesson. Go ahead and do the lesson check, and we'll talk about it next time we meet in class.